Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshed Ali and my role ID is 190994. So today I'm going to introduce you about the introduction and implementation of serial communication USART of using ATMEGA 328P. So first of all, we have a simple introduction about the serial communication and embedded electronics. So embedded electronics is all about interlinking circuit, processor or other integrated circuits to create symbiotic system. In order for those individual circuits to swap their information, they must share a common communication protocol. Hundreds of communication protocol have been defined to achieve this data exchange, and in general each can be separated into one of the two categories, parallel or serial. So in this type of serial communication, we are going to perform the basic operations such as the parallel as well as serial. So the task we are going to perform, it's act as a slave and master. So the slave will get the value and then give to the master, and then with by defining or by deciding the master, it will give the us our output. So parallel interfaces transfer multiple bits at the same time. They usually requires buses of data transmitting across 8, 16 or more bytes. Data is transferred in huge crashing waves of ones and zeros. So this is the basic an 8-bit data bus controlled by a clock transmitting a byte every clock pulse. 9 bytes are used here. 9 bytes used with the help of clock, transmitting data from output to input and input to output in a serial communication system. So these are basic terminologies using synchronous or asynchronous, where we are going to use clock. So in serial communication, the transmitting and receiving device must be synchronized to one another and use a common data rate and protocol. Synchronization allows both the transmitter and receiver to be expecting data transmission reception at the same time. There are two basic methods of maintaining signs between the transmitter and receiver, asynchronous and synchronous. In asynchronous serial communication, such as the USART board, that ATMEGA 15 framing bits are used at the beginning and end of a data type. But in synchronous, the transmitter and receiver, by employing a common clock between two devices, data bits are sent and received on the edge of the clock. This allows data transfer rates higher than with asynchronous techniques, but requires two lines data and clock to connect the receiver and transmitter. So here are some tools. The first is duplex, simplex, half laps, full duplex, half duplex. So simplex, separate lines for transmission reception, only reception or transmission at a time. In half duplex, can transmit or receive but one at a time, but in full duplex can transmit and receive simultaneously. So this is the baud rate. Data transmission rates are typically specified as a baud or bits per second rate. For example, 9600 baud indicates data are being transferred at 9600 bits per second. So the non-return to zero coding format, there are many different coding standards used within serial communications. So that ATMEGA 16 uses a non-return to zero coding standard. So in non-return to zero coding, a logic 1 is signaled by a logic high during the entire time, and whereas a logic 0 is signaled by a logic low during the entire time. So the parity, as we know, parity is to further enhance data integrity during transmission. Parity techniques may be used. Parity is an additional bit that may be transmitted with a data byte. So in even parity, there are two types of parities, even and odd. So in even parity, the parity bit is set to 1 or 0, such that the number of ones in the data type including the parity bit is even. So if we are talking about the odd parity, the odd parity is set to the 1 or 0, such that the number of ones in the data byte including the parity bit is odd. So at that receiver, the number of the bits within a data byte including a parity bit are counted to ensure the parity has not changed, indicating an error during the transmission. So the protocol of serial communication in AVR are the USART, SPI, TWI, twin wire interface or inter-integrated circuits. So we are going to perform our lab tasks using universal synchronous asynchronous communication. So this is our lab task. Here we implemented first for SPI serial port peripheral interface for slave. Now you can see here, first of all we have to define the frequency and headers for our SPI. So LCD for SPI is our header files, including So after defining this MISO for after defining our main function, we initialize the LCD function, call and function, and setting the one to the MISO, and then with the help of this DDR bit register is set to the output, and then it compares the value with the SPCR. While comparing, it will send the our SPDR data to our LCD. Right. So here we are going to write a data. So the data is right in the now slave. So now the master, for this is for the master. So first of all we have to initial define all the frequency headers, delay function, and define all the our pins MISI, MISO, and SS2. So for sending data we have to initialize the character database for 4789 VN 456 static 123 minus 00 is equal to plus plus. So these are the database characters. So a1, a2, a3 are the our functions we are calling. So void search for our searching operation. So after initializing integers, we have to store our code. So first of all we have to call our str function. So its library is our header file is at main. So this is our main function. So we have to set the DDR port D register as an output by sending our maximum value, and then with the help of a while loop we have to read input from the port D. So the input we are giving from to the port D is read by this operation, and then our uh, port D value is sent to the such as if our 0xEF send it to the port D, then it will print D, then it will this operation is converted to X, and then X will compare its equation. If it is 0, then it again it will return, and then again it will search. So if 0xDF sent to port D, then print D data is sent to the X, and then it will compare and again search, and as it is as 0xBF, 0xSF, and after it will move to our next row, such as here it will compare its the previous X value to our 0x0f. So in database it will send to the data a1, and then it will compare if it is condition output true, and then it will send data a2 and with the delay of proper, and then send the maximum 0x0f value to the our port D, as it is for the a3 and as it is for the a4. So this is the ranging array database, and then with the help of this function send data character u, it will compare when the SS is 1, then it will compare the function to the u, and then by comparing with the our SPI flag, then it will send SPR main data to our port D. So at this case our port BL is 1. So after it will call MSTR initialization function. So when the direction register 1 are both are 1, then it will in this case SPR is also 1 to our clear our main header. So after it we have to clear our all the inputs and outputs on our LCD or crystal display. So this is the basic code for our slave and master. So this is our Proteus simulation. Now I'm going to show you the Proteus simulation on our Proteus circuit as well. So this is the basic Proteus simulation of our serial communication. First of all, I am here uploaded our hex files of our slave and for our master, which we are creating with the help of our ATMEGA Studio simulation. So now you can see here if I am operating one operation and then one, then positive operation and then one, and then equal to, and then 2. So the data is sent to the slave, and then with the help of master it will appear on our LCD liquid crystal display. So now it concludes that the serial communication is a vital part in the area of electronics and embedded system as well. So the rate of data transfer is critical if two devices want to exchange information on the same bus. Hence the most important method is to serial communication is to parallel. So it is commonly used with which to exchange data between computers and peripheral devices. Serial communication between the sender and receiver are subjected to strict protocols which provide security and reliability and have led to its longevity. So many devices from personal computers to mobile devices make use of serial communication. So that's all from my side. Jazakallah.